All right. So yes, as mentioned, this week we are going over self-RAG. So it's just one in kind of a few different papers we had shortlisted for um, the work that's really kind of happening to improve retrieval augmented generation. And it's really interesting because yeah, I was talking, we were mentioning it with Henry, like we covered RAG itself, I think about a year and a half ago. So it's super cool to see how it's kind of really taken off and all the different approaches and like renewed interest in this area. Um, so this paper specifically is trying to actually, so it's learning to retrieve, generate, and critique through self-reflection. So I think the main problem this is tackling, right, is right now, usually RAG isn't actually built into the model, right? You have perhaps an agent or some other orchestrator or something that is responsible for actually finding the documents and then passing that to the language model and then having that kind of output. But that kind of decision on when to retrieve documents, um, and then how to retrieve it, how to check that it's like useful, factual, and all of that is usually not handled by the language model at all, right? That's handled by the logic that you write. And that's something that this paper tackles. It actually tries to train the language model to come up with tokens that will that are trained to figure out when it should retrieve. Like, is retrieving at this point useful or not? And then it also has a critique token that will kind of evaluate, are the retrieved documents useful or not? So they're actually kind of building out this training pipeline for a language model to determine when to retrieve and then evaluating retrieval without having this kind of independent kind of orchestrator that most systems use right now. So this is a nice diagram that they put up. It kind of shows the before and like before as in like RAG, like vanilla RAG, and then how they've kind of rethought self-RAG, right? So in retrieval augmented generation, right, as we all probably know at this point, it has this question, right? And then you have this a retriever that's like not part of the language model at all, but will go in and retrieve some number of documents, and then you reprompt the language model with those documents and tell it to generate, right? So now it has both the documents as reference as well as its like previous text, and then it kind of generates the next output with the new context that it has. Yeah, so that's kind of how that's set up. Inherently, it has no way to determine when to retrieve, when to not retrieve, and inherently, it also doesn't have any way of kind of evaluating the sources that it has received. So the language model is kind of pretty, I would want to say, dumb in this scenario with regards to if you feed it absolute garbage, it's going to just generate absolute garbage. And it's also going to not really know, oh, do I actually need this information for my next output or not? So that's what at least self-RAG is trying to do and improve. So you can see that in self-reflective RAG, what they do is they predict this retrieve token, right? And then retrieve kind of has these different, it spawns off like different retrieval at the same time. And it figures out, and then it also has this other token. This is like the critic token. And that kind of determines, this kind of irrelevant, supported, partial. And then finally in step 3, the critic outputs and selects the best segment. And here you can see that the output is kind of I mean, it's kind of automatically determining from the retrieved documents what's the most important and relevant, and putting that into the language model. So it's actually, this whole thing is actually a trade. They have a training and inference built into this, and they use a Llama 2 model and train it to figure out when to generate these retrieve and critic tokens, essentially. So yeah, like pretty different. I think it has a lot of potential, honestly. They also have a code base, so we can try it out. I haven't done that yet, but yeah, it's like a very different paradigm than having the language model be completely isolated from the whole retrieval and generation part of things. So here it's actually, it's training the language model itself, when to retrieve and then what's relevant from those entries in order to generate.
So this is question here. So is this very similar to decomposed prompting, where let's say you might like just have some explanations around it, and then like you use that explanations to generate the model, but here they add an additional step of retrieval, right?
So what's decomposed prompting? Actually, I'm not familiar.
So I think it's more like let's say given some prompt, like prompt to the model, right? It kind of generates some intermediate steps, right, or at least some reasoning or explanations.
Oh, like chain of
And
thought?
then, yeah, it's similar to chain of thoughts, but where probably uh, it tries to generate something, let's say sees whether that is correct or not, like factual verification in a way, verification step, and then again like generate additional context. So like you see generate verify, similar to that, like similar in chain of thought fashion. So I'm just wondering in this one, right? Is it like just figuring out like what to retrieve, or based on this critic tokens, or it actually let's say add some explanation or like information in context as well, like we see apart from retrieving in this setup.
What's some information? I'm not sure I understand your question.
So I was just wondering. So right now you mentioned, right, that like they have this critic outputs, right, and then they select the best segment.
Mm-hmm.
And let's say the model here tries to also maybe retrieve the uh, let's say uh, documents, right, relevant documents, and then generate it, right? So is this done in to and fro, or like is it like just one like they just have this end uh, chain like chain of thought similar approach, and then just rank it, like how is it?
So yeah, so I think the thing here is that it's actually learning to predict these tokens, right? So the retrieve thing, like, so you see these boxes, those are actually tokens that it is learning to predict. So it might be a little more clear when we go through it. So yeah, this one, I think this slide is helpful because at every segment or sentence, right, what it's doing is it has these three steps, right? So first it determines, um, it decodes a retrieval token to evaluate the utility of retrieval and control the retrieval component. If retrieval is required, the language model calls a retrieval model to find the top relevant documents. So it's actually, this is like a token that it's like predicting the probability of it. If it's higher, then it's like a controllable thing, right? You can set some hyperparameter and tune it such that if it's like higher than some threshold, you'll retrieve. So they kind of use this also to allow you as a user to have some composability, what's it called? Like ability to determine like how much it references things versus not, if you want that kind of ability to manipulate the model. But yeah, based off of this token, it's determining when to retrieve versus not retrieve. And if it's helpful, if it determines that retrieval is useful, then it calls the retrieval module. And then in generating, right, if retrieval is not required, it just acts like a normal language model and will predict the next output segment. But if retrieval is required, then the model first generates the critic token. This will evaluate whether the retrieved documents are relevant for each of the kind of responses, and then it and then generation continued conditioned on the retrieve. So then it does like a conditional generation.
So one thing, let's say when it tries to generate, right? Like, decide like upon whether to retrieve or not, right?
Mm-hmm.
Uh, do they also include some, let's say, set of what do I mean?
Some set of what?
So like let's say query refining or like they don't do it right now in the setup or like how is it like so let's say for example, right, when I'm trying to generate something, let's say the predict token decides that I need to retrieve something, right? So when like let's say I want to retrieve something, right? So do they also refine the queries or like how is it right now, like the setup that they have?
Refine the queries. Oh, you're saying like a prompt for the retrieval module?
Yeah. So basically, because like let's say model like now acts as a critic, right? So at least maybe it has some in let's say way right about what is required or what is not, right? So does it generate some legacy or update the queries so that legacy then further in the next step the retrieval is like the documents which are retrieved are more relevant or like yeah, I'm just wondering.
Yeah, I don't think it. I don't think it attunes the prompt, or I think the prompt is standard. I actually have the prompt here somewhere. Yeah, so this is okay. This is the critic prompt. So I think they have another prompt like this for retrieval too. The critic one is just given an instruction, make a judgment on whether finding some external documents from the web helps to generate a better response. So that's I think this is the one, the reflection token. So this helps you determine if you're going to retrieve or not. And then they have similar ones for the other two as well. So yeah, I think the prompt is standard. It's, yeah,
I had another question.
yeah.
Um, like what do this do in a scenario where retrieval is required, but critic says that the retrieved documents are not good enough as a support for the query?
I mean, I don't think they've built in like a loop or anything. What I understand is it'll just choose the best ones out of the retrieved segments.
So are they like oversampling?
Sorry?
Like are they oversampling the retrieved segments? Meaning that they are like retrieving a couple of um different retrieved documents and then evaluating um using the critic how each one of them is relevant for the given query and then choosing the best one of them.
Yeah. Generally, most of these RAG pipelines are built where they have a fetch K and then a top K. So they first fetch a large sample, and then from there you kind of select the like if you've looked at, so this is just like an implementation thing, but if you there's like a lot of I think a common RAG paradigm right now is there's like map reduce chains that will take all of them. First I'll take like the fetch case, so like some 20, 30 chunks, and then from that it'll run like another evaluator chain that says from each of these chunks what are the most relevant pieces, right? And then I'll pull out those context because it's yeah, and then it'll just use all of those segments in the output. So generally, I mean, that's the general paradigm for RAG is like, yeah, you first fetch a large sample, then from that you kind of condense it. It is possible to like just pass in everything, but generally speaking, like that's gonna over burden your context window, right? So yeah, I think it's the same thing. Like they are assuming that they fetch some number of documents, and then based off of how the critic token determines, it will filter some subset
Okay.
of it. Cool. And then yeah, I think some of the other questions will probably be a little more clear once we get through the rest of it. Okay, so yeah, this is just again an overview. So what this is really trying to achieve is having the language model itself be able to combat like factual inaccuracies. So self-RAG, as I said, it trains a single, arbitrary language model. They use Llama 2 that adaptively retrieves passages on demand. and generates and reflects on retrieved passages and its own generations using reflection tokens. And generating reflection tokens makes the language model controllable during the inference phase, enabling it to tailor its behavior to diverse task requirements. So what it's saying by that is like so each of these tokens are controllable in the sense that it has some hyperparameter like setting saying that if I think it's over this threshold or something, I will use it. But you can kind of control that as the user or the trainer of this language model, right? Because yeah, if you wanted to always retrieve facts, you can kind of tune how the language model uses the retrieval token to kind of default to always retrieving or not, and same with the critic. So it's kind of making this process more controllable. And then, yeah, it's also kind of building in RAG into the language model. So yeah, this is kind of a little more about how it is training and controlling the language model with the self-reflection tokens. So there are different types of reflection tokens that are added to the self-RAG vocabulary during training. And here you can see there's 4 of them. Retrieve is rel, is relevant, is sup, which is supported, and is use is useful. So yeah, these are the 4 reflection tokens used in self-RAG. Each type uses several tokens to represent its output values. The bottom 3 rows are 3 types of critic tokens, and the bold text indicates the most desirable critic token. X, Y, D indicate input, output, and relevant passive, respectively. Yeah. So yeah, any questions on this? So essentially, retrieve can either be yes, no, or continue. I'm not sure what continue is actually. Yeah, anyway, so it decides when to retrieve with the retriever. And then these 3 tokens are critics. So based off of the retrieved content, it will kind of evaluate the response, right? So is relevant says, hey, does D provide useful information to solve X? Is supported, all the verification worthy statements in Y is supported by D. So this is kind of, I think you can treat both of these as like a precision recall. So one of them is like, is this useful? And then can I actually support all of the claims I've made based off of the data I've retrieved? And then I think is useful is just kind of an overall token. Yeah, again, I think going like actually looking at how these tokens are set up would be helpful. But yeah, these are the tokens that they have added to the vocabulary. So the language model now learns how to generate these values, right? Essentially, as it, decodes the next output. Yeah. So this we covered this, but this is kind of that loop, right, of how it is generating these tokens and determining what to do based on that, right? So if it decodes a retrieval token, it will then predict through conditional generation the output, right? And then it will do a critic step, right? If retrieval is required, the model evaluates if the passages support generation. So that's how it generates these 3. And then I think based on this, there's also some logic to actually, yeah, there are a few more details in this, obviously. I think based off of this, it then has to determine kind of this part, right? Like how it's going to use those retrieve segments in the conditional generation. So there is a slide on that. Okay, so it just kind of passes it in here. So after, we'll go through, yeah, let's go in sequence. So this is kind of the training process, right? So self-RAG training consists of these 3 different components, the retriever, critic, and generator. So first they train the critic and augment diverse instruction output data with retrieved passages from the retriever with reflection tokens. Yeah, and we'll go into the data set creation right after this. And then after that, they train the generator language model using a standard next token prediction objective to get it to just generate natural continuations. So as you can see here in this diagram, like if for each of this one, the input here is like write an essay of your best summer vacation. So at each kind of next sentence, it determined, hey, no retrieval is necessary. This isn't like a factual thing at all. But then for the other one, right? How did the US states get their names? What it's doing is it determined, hey, I need to retrieve. And then this is kind of the output of the retriever, I believe. It kind of spits out that content of the 50 states, 11 are named after an individual person. And then the critic kind of generates another token as relevant based off of that text. And then based off of that, yeah, I think what I understand is these steps are done in parallel. So then from that, it generates conditionally based off of that retrieved content. 11 of 50 states names comes from person. Okay, I think there's a typo there. And then the critic says it's supported. So this statement is supported by the context that was retrieved. And then again, it retrieves one more time. I believe what it said in the diagram above is that these retrieval steps are all done in parallel. Yeah, so generate segments in parallel for each of them. So that's what's happening here. And it retrieves again, and now it retrieves Louisiana is named in honor of Louis the 14th of France. Again, the critic token says it's relevant. And then it generates conditionally. For instance, Louisiana was named after King Louis the 14th, and Georgia was named after King George II. And then at this point, the critic token says that this is like partially, and I think partially means that, again, as you can see, I kind of generated an additional fact about King George. So that's why it's saying that it isn't entirely supported by the retrieved data. Again, I think a natural follow-up on this, if we have time at the end, they have published their code base, so we can also look through it. But yeah, I think it's obviously super interesting paradigm. Okay, so this is the data collection. They had to collect a data set for this critic model, right? So that it can kind of better understand the supported, the relevant, partially, like each of these tokens that it's trying to predict, right? So they create a supervised data set by prompting GPT-4 to generate reflection tokens. And then they distill their knowledge into an in-house Model C. For each group of reflection tokens, they randomly sample instances from the original training data. And yeah, this is kind of how that is set up. So they're creating this data set so that it best learns how to determine the values of these reflection tokens. So given an instruction, make a judgment on whether finding some external documents. This is what I read this, right? Helps generate a better response. And then followed by a few short demonstrations on if the original task input X and output Y to predict an appropriate reflection token as text. Probability of reflection token conditioned on the input, output. Oh, demonstrations are L actually, sorry. Yeah, so this is kind of how they create this like supervised data set on how to, what's it called? How to predict if the demonstrations are useful. Yeah, and they distill knowledge from this GPT-4 model into the Llama model by having it first generate all of these data points and then kind of have a distillation phase, I guess. I think distillation is just honestly, they create the data set with GPT-4 and then they train it on Model C so it can learn to predict whatever GPT-4 came up with. And they said that the critic achieves higher than 90% agreement with the GPT-4 based predictions. So they're able to kind of match it on this one task pretty well. Yeah, so this is just the critic learning, right? So how they're actually training the critic. After collecting training data, dcritic, they initialize C with the pre-trained language model and train it on this training data set, dcritic, using a standard conditional language modeling objective, maximizing likelihood. Yeah, so this is what I just mentioned in the previous slide. So here, this is back to the days of like actual conditional language modeling, where you couldn't just like tell your language model, write this like in a positive tone or write this in a funny tone. You actually had to conditionally train it. But yeah, anyway, that's what they're doing here is they're taking the condition maximum likelihood conditioned on the input and output for each of the reflection tokens. And they use llama to 7b for the critic initialization. And then they come to the conclusion that the critic achieves like very high parity with the GPT-4 based predictions. Does that part sound good? Yeah, I think just to boil it down, they create the data set, and then they train the llama model to be able to behave like GPT-4 on the specific task.
So how many samples were required to achieve this? So like how many samples did they generate from GPT-4?
If I remember right, it was quite a bit. I don't remember. I mean, I can check. I didn't write it down though. Training the generator. They collect 4,000 to 20,000 supervised training data points. And combine them to form the training data for the critic.
I see. And also, just maybe make sure that I follow it correctly. So let's say when critic model generates like let's say some token, create reflection tokens, right, for each particular let's say document and like some supported query, uh, let's say span of text, right, basically supporting the query. Then is it like the entire document like or this portion of documents which are not relevant like are thrown away or like how is it or like also that is also fed into the context, but you then additionally feed like all this like reflection tokens with like the different spans to make the model like more aware about like what is relevant or not, like how is it, like could you maybe just clarify once in case
Yeah,
I
that's a
missed?
good question. I mean, to my understanding, I don't think I mean, I guess there's two options. I have to double check which they actually do. My current understanding is since they do have, since it is conditionally generated, whatever this comes up with, partially relevant, unrelevant, I think that's also passed into the next generation. So if the token is like, this is irrelevant, I think in the training process, it'll like ignore that. I'm not sure. I didn't read, at least in my read of the paper, I didn't see anywhere that they're like throwing
I
things
see.
out. But I think it's just conditionally generated to respond accordingly based off of what the critic said.
Okay, let's see. Yeah, because I think in the initial diagram that you showed, right, like they had this different like prompts generation in parallel, right? So this
Mhm.
is, I was asking if like they actually like pass all this information in context or they just like
Yeah, I mean, the diagram, again, I guess it's a diagram. It'd probably be best that we just take a quick look at
yeah in the code. Yeah.
um, because I'm also unclear how they're really doing this in parallel because
Yeah, like in terms of if they're doing conditioning, right, then it's
yeah.
maybe
Because
not
also
possible.
if you look at step 3, there's like 1 greater than 3 greater than 2. So it looks like, and that's also how they. So maybe what's happening is they yeah, I think probably what's happening is you can run the retriever in parallel, right? So that comes up with these 3 different
So
kind of.
maybe it might be something like let's say for a single query, there might be different documents. So maybe you run retrieval in parallel, and then maybe there's different subset or there post retrieval. Those I think are conditioning.
Yeah, so I think what's happening is after it gets the retrieved ones, it uses the output of the critic. So the critic here is going to say supported, irrelevant, partially. And then based off of that, it handles evaluation sequentially based off of like how strong the critic rated the response.
Yes, yes. Interesting.
Is my correct, like understanding from what I read, but yeah, we can also just take a quick pass on how they implemented it.
Yeah, it makes sense.
Yeah, I mean, I think that also kind of follows this diagram that they have, right, for how it's ordered. Okay, so this is the critic learning. And then inference, right? So for inference of self-RAG, by learning to generate reflection tokens, self-RAG enables to tailor model behaviors for diverse downstream tasks or preferences. And one, adaptive retrieval with retrieval tokens. Previous work only retrieves passages at fixed times, and it always does that, right? It's not like something that's learned. I think this is what we were touching upon earlier, is like by actually training the language model to generate these tokens and figure out when to retrieve or not, it's now the language model understands that, right? It's not this third-party orchestrator that kind of does it either all the time or has its own kind of logic on when to retrieve, when to not retrieve. And then it learns to generate retrieval tokens to adaptively retrieve, and you can change frequency based on their soft constraints. So like as someone fine-tuning this model for your own use case, right? You can kind of control it a little bit to change the frequency based off of soft constraints for these new tokens. And then there's also this tree decoding with critic tokens. So there's multiple fine-grained critic tokens evaluating different aspects, right? So this is what we were talking about for the precision recall is useful. And there's different like values it can take on. One that is useful is like a numerical scale, and the other ones were just like, I think, enums that you can assign. And then, so these are all like different approaches that you can use for training the critic token. And it segments segment level beam search using linear interpolation of desirable critic token probabilities. Yes. Oh, okay. So I guess this kind of explains that, right? In beam search, they're actually taking like the critic tokens feedback, I think, in order to kind of do this conditional generation based off of those values. So, okay, I think this will probably also help. This is like a little algorithm block for self-RAG inference. Yeah, so the generator language model, there's the retriever, and there's a large scale of passage collections, D1 through N. The input is an input prompt X, and preceding generation Y were less than T. The output is the next output segment YT. The language model predicts the token retrieved given X and all of the previous context. If retrieve is true, then it retrieves relevant text passages D using the retriever given the current token and all of the past tokens. The language model predicts these three critic tokens is relevant given X, the retrieved passage tokens, and Y of T and the history, given X, D, and Y less than T for each D, for each document retrieved. And then M also predicts is supported and is useful, given that same data for each document. And then, got it. Okay, so this is what we were mentioning, right? So here it ranks Y of T based off of is relevant, is supported, and is useful. And if retrieve is no, then it just predicts the next token given X, and it predicts is useful given X and Y of T. So there's kind of no retrieval step. Any questions on this?
So essentially, they are choosing one, like the best document out of the D documents uh, as an output segment.
Yeah. I mean, I guess, right? I don't think they're selecting, right? But they're just ranking it based off of the values in these 3 critic tokens.
So, like I'm a little bit confused regarding this part. Are they generating like D segments in that case? Like
They're not
segments meaning,
generating. D isn't generated text, right? D is the relevant, the retrieved documents.
yeah. But based on the retrieve docs, they are assigning scores.
Yes.
And like my question is that in the generation pipeline, are they using this? So basically using the retrieve documents, they are generating the next segment, and they have to use this next segment for their um like they have like these D next segments, and they have to choose like one of them, right? They can't use
So I
all the
think
segments.
my understanding here is that they're not actually, this step isn't actually generating the next set of tokens. I mean, not like text. It's just predicting these values. So it hasn't actually generated its own response yet, right? It's just predicting, hey, based off of, so right, this is the input prompt X and the previous generation and the document. It's saying, hey, is the documents useful, right? So that's all this is doing.
Okay.
And then, okay, actually, is Y, so Y of T is like the output, right? Is the output token. So yeah, the preceding generation is Y like less than T. And then the output is the next output segment Y of T. Yes, you're right. So it is,
Generating given a document
yeah,
each
it
time.
is generating that. And then based off of the generation, it's predicting these 3 things.
Mhm.
Okay, so I guess it says detailed in section 3.3. Yeah, maybe I can share that. Maybe we can go over it a little bit because it's not. Yeah, I'm curious how once they have these like 3 or 4 different potential output segments, how are they actually combining them, right? I guess that's the question.
Right.
Um,
Like at least from their algorithm, it seems that they are using all the segments for generation.
yeah, let's see. Okay, so
Seems that for each document, right, they are generating something, and then basically, let's say it is relevant or not, right? Then they compose everything like based on that ranking and together, right? And then generate the final step, right? Or something like that.
Um,
So more like for each document, right, they'll get some output.
yeah,
And for each output, right, they check whether it's relevant or not, right? And I think then also they check it like whether it's supported or not, right? And depending on the cases, right, where it's relevant and supported, then maybe they combine everything at the final step, everything together, and then generate a one last, like something like that. So,
hmm
so that's my understanding. Maybe.
yeah, I mean, I think so. So as it's saying, right, at each segment, step T, based off of the conditions, it retrieves the passages and then processes each passage in parallel and outputs different continuation candidates, right? And then they conduct a segment level beam search with beam size B to obtain the top B segment continuations at each timestamp. And okay, so this kind of makes sense, right? So they are generating all these different candidates, right? Which is an output based off conditioned on the retrieved documents. And then in their beam search, they determine which is the best sequence based on that. And then the score of each segment YFT with respect to passage D is updated with the critic score S. That is the linear weighted sum of the normalized probability of each critic token type. For each critic token group, G, we denote its score at timestamp T as STG, and we compute a segment score as follows. Okay, so All right, so this is some function, right, based off of the generated y of t conditioned on x, the documents, the history, plus this critic token, where the critic token is a linear combination of like the different types of critic tokens, right? WGST of G, okay, some linear combination of those. Oh wow, they also have, what is P of T? Where it stands for the generation probability of the most desirable reflection token. R for the critic token type G with NG distinct tokens. The weights WG are hyperparameters that can be adjusted at inference time to enable customized behaviors at test time. For instance, to ensure that result Y is mostly supported by evidence, we can set a weight term for the is supported score higher, while relatively lowering weights for other aspects. Alternatively, we could further enforce hard constraints during decoding using critic. Interesting. Oh, okay. So they also have that option, right? Instead of using a soft reward function in equation 4 here, right? We could explicitly filter out a segment continuation when the model generates an undesirable critic token. No support. So right now they're just kind of weighting the values from each of these tokens, right? But this would be kind of what you're asking in the beginning. If it's like an undesirable token, I mean, I guess they're not doing that right now, but you technically could, right? And then, yeah, balancing the trade-off between multiple preferences has been studied in RLHF, which often requires training to change models' behaviors. Self-RAG, tailors, and LM with no additional training. Okay, does this kind of answer your questions? I think it is more clear now. So they're tuning a few different parameters, right? So this is how they're kind of evaluating all of these different tokens and kind of combining them. And then they're computing a score for each of these segments that is then used in beam search to determine which is the best segment at that timestamp. So it takes the generated output, the documents, and whatever the critic token is. It scores the critic token based off of like this linear combination of all the different types of critic tokens. And then it adds that to the language models, like probability of generating this Y of t given all the content it has. And based off of that, in beam search, it determines the best sequence based on all of this information.
Yeah. But I guess that means that they are computing the whole score for the beam using all the set of documents in the like retrieved by the retriever, right?
Wait, sorry, say that one more time. They are computing what?
Like they have like these n beams, and for each of these beams they are computing the whole critic score for all the retrieved documents, and then they are choosing the beam with the
The best output score. Yeah.
yeah, got it.
Yeah. So they're doing the segment level beam search essentially. So they have all these parallelly generated output case with different continuation candidates, and then based off of this kind of scoring function, right? They choose the best output segment.
Right.
Yeah, pretty interesting, I think, honestly. Okay, let's go back to this. Okay, and then results. I mean, I think the TLDR of this is self-RAG 7B, 13B performs better than, I mean, I don't know, I don't remember, we can check what their baselines are. They have a baseline with retrieval, baselines without retrieval, language models with proprietary data. Baselines with retrieval, I don't know, obviously, what the parameters of the retrieval are. Maybe they've included it in their paper, but they're able to show it's doing better, which I think is the main takeaway from this table. And they also run some ablations to show kind of how the different components, right? The retriever, the critic, and then also kind of each of these different types of tokens how you can emphasize one of them versus the other, like right, and like how the paper, right, we were seeing how they had those different scoring functions for how the model takes into consideration the different token types. Yeah, they have kind of did some ablations about each of them, right, and how they how it factors in. And yeah, I think that's it for the slides. But any questions? We can also, I think we're almost out of time, but it could also, yeah, their code base is also already published. So yeah, could be neat. I mean, I think that's definitely a con of RAG right now. I still think most people will do simple RAG because there's no training involved at all. But because of that, right, you do need to set up like some sort of a prompt system or some sort of an agent or some sort of like an orchestration layer such that it's really like more, yeah, it's the language model has very little understanding, and then it also has no kind of fine-grained control over the documents. You're really relying on a system of prompts, right, to determine like which chunks are relevant, all of that when you feed it to the language model. And there's no kind of tree decoding, like generating multiple options, figuring out which is best. None of that. So yeah, okay. Any thoughts before, or things you want to kind of cover from the paper? Yes, I mean, I think we covered almost everything in this paper. They have a lot at the bottom regarding all the prompts they used and more, yeah, kind of analysis on each of these tokens, how they're set up. So if you're like interested, you can like go through that. Yeah, there's also this for training, how they trained it. Oh, this could, yeah. This is how they train the critic language model, right? So they sample data from this XY. So okay, we'll go over this quickly. I think this is important. So the input data D is from this, this is what we mentioned, right? So they take GPT-4 in order to generate these values. So like, is something important or not from the generator, and then they initialize C, which is in this case the llama model. They sample from X and Y. From X sample Y, prompt GPT-4 to collect a reflection token R for X and Y. Add that to the critic, to the data set. Update the C model, critic learning equation 1. Okay, we can look at that. With the next token prediction loss, initialize M with the pre-trained language model. For each sample, run C, the critic model, to predict the reflection token given X and Y. Add that to the dgen dataset, and then update M on dgen with next token prediction loss. Yeah, so this is details of how they create that data set. Yeah, this is, I mean, I think they've done a lot in this paper that's like very different than normal language model generation. So, yeah. I mean, I think I'll definitely play around with the code base and see how usable it is. But yeah, I guess these are like examples of what it's doing. So give an example of a situation where you have to delegate tasks. Retrieve no, the manager realizes that there's an extensive list of tasks that need to be completed in order to make an event a success. Retrieve, it gets a lot of information about delegation, determines that's relevant, and then generates the next Output says this is partially supported by this context. And then after that, it determines for the next sentence to not retrieve. So it doesn't retrieve. Again, it doesn't retrieve. And then here it determines, yes, I should retrieve. It retrieves all of these data and subject matter experts, et cetera, et cetera. Okay, cool. Yeah, I guess obviously feel free to go through this. Maybe in our Discord group we can kind of discuss if people give it a shot on their own kind of use cases and how that works. But yeah, I think that's it for the meeting today. Yeah, anything else you guys want to discuss before we end?
So basically they have this assumption that the retrieved documents are always factually correct, right? Have you ever come across a scenario where the retrieved documents are incorrect?
I mean, I guess the premise here is that you're passing it. The idea is the language model hallucinates, your documents don't hallucinate. Right?
Yeah.
I don't think that's a premise these things are working on top of. Yeah, the idea I think generally, because then if you want to evaluate the factuality of your documents, then there needs to be some other ground truth. There has to be some ground truth. And right now, yeah, I think all of these have a ground truth that your document or your data set is actually correct.
Got it.